Well, I got through it. Did both of you, were you able to get through the quiz?
I got through it.
Nice.
How about you?
I was just missing 13.
Okay.
I was working on 12.
Okay. Well, we can get there, and we'll just go down the list, and yeah, we'll get there when we get there.
Okay. So question 3, I put we assume the standard deviation is unknown.
Let's see. Which am I on the wrong one?
No,
Did I download the wrong quiz?
Looks like we're at lesson 10 group meeting.
What did I do? Anything's possible today. I was trying to rush to get here for the birthday, so I did my homework.
Oh.
Hang on. Did I do the wrong one? Oh my gosh, I did.
Which one?
I did next week's.
Oh, you did lesson 11?
Yes.
Oh, that's okay. Well, you're all set for the next meeting then.
I even named it lesson 11. Meeting. Oh my gosh, you guys, I'm so sorry.
That's okay. Hey, no problem. No worries. So what I can do is Alan and I, we can go through it, and if you have questions about it, we can run you through it. And if you don't, then we'll just chug through. Okay.
I'm gonna start it so I can see what the questions are.
Okay, for 3, I didn't see that it was 3 decimals, but I put 16.45.
Yep, that's what I put.
16.45, but like we need one more decimal.
Yeah, I mean, it says around 3 decimal places, but there's been some other questions that have done the same thing, and I just put a 0 at the end of it. And that's okay. Yeah, I think that's just fine.
Okay, so yeah, so 16.450, I guess.
Yeah, I feel pretty good about that. And the thing is, mine, yeah.
Number 4, it says, which of the following statement is true?
Well, first off, Stephanie, are you at a spot where you're able to see question number 3 on lesson 10 quiz?
Yeah, which of the following statements is true?
Oh, wait, hang on. Question 3 it's actually one that you have to input something, like a number.
Into the applet?
No, it's so lesson 10 group meeting quiz. Are you on that one?
So, yeah, that was the one where you said was 16.45 or 5
Yeah.
Okay.
So anyway, that's what we put down. So yeah, question 4, now it's which of the following is true. Yeah.
Okay. Which of the following is true?
I put
Go
A.
for it.
You put A?
I put A. But I wasn't sure about this one. This one is tricky.
Is it C or B?
I put down B, and the reason why I put down B is in the book.
Yeah, I think that's right.
Let's see if I can find it here. 3.1 in the book. Let me share my screen really quick. I'm just going to share it with you real quick here.
Gosh, I feel horrible. I am not here.
Oh, it's all good. We've all been there.
Well, I'm set for next week, you guys.
You're all set, yeah. So if we're stuck, then you can help us. Anyway, here's the point estimators. This graph right here. Anyway, it says the statistics above, which is this column here. These statistics are called point estimators because they're just one number that's used to estimate a parameter. So the question is asking. So X is a point estimator of mu.
Yeah, I agree.
And right there. So that's
okay,
point estimate of mu. If it's wrong, then I have no idea what it means, but that's what I got.
Okay. For number 5, I got 526.
That's what I got. I got 526.
What's just because just a standard number 526?
hmm
What was the formula that you?
So let me find it in the book here. So they're looking for the point estimate, and the way you do the point estimate is
There's no formula.
There's
It's given to you.
right, but there's a formula that will give you multiple things.
Mhm.
Okay.
This one.
But like Alan was saying, it's given to you in the.
Yeah, the X with a little line at the top, that's your point estimate.
Yeah, 1.96. Hang on. I'm going to show you. Oh, there it is. Okay. So let me go back to my screen share here. Oh, it looks like I'm still sharing my screen. Okay. So there it is right there. So this part of the equation, this is the point estimate right here. So X, or just the average, the mean, whatever. And then this whole thing right here, the 1.96 times sigma divided by the square root of n, that represents the margin of error for whatever your percent confidence is.
And the 1.96 is always, that's part of the formula, or just because of?
So that is for the 95% confidence interval.
Okay.
Yep. Now, if you have like a 90% confidence interval, this is actually going to change, and it's going to change to, I've got it in here, 1.645. Yep.
Okay, so it's just on the reading. Okay.
Yep.
Perfect.
Anyway, that's all for now. Okay, so that's good. We said 526, right?
Yes.
Okay. Question 6, my answer was 27.685.
I put 28.
Okay, yeah, that's probably what it should be.
They say like to round it up, right?
Let's see.
This one didn't say.
This one didn't say. So I feel like it probably wouldn't matter or wouldn't make much of a difference because it would be 28.
So you got 27.865?
27.685.
Okay. So for number 7, or do you have a question on number 6, Stephanie?
Oh, you just use that same formula, but you're just using the. Hold on. What's the margin?
It was a different. It's a different.
Yeah, that is different.
It's a different formula.
Okay, but it's all. I can just get it from the reading. I don't want to hold your days up.
Yeah. Okay. Question 7. I got 498.315.
Ooh, let me get those points because I put 498, but I didn't put the decimals.
Oh, okay.
3 decimals.
498.315.
Okay. Yeah, that's probably what I got. I got 498, but for some reason, like in the reading, like in the video, said like that we need to round to like the whole number.
Mm-hmm.
That's why I've been doing the whole numbers. I haven't been paying attention to.
Gotcha. Yeah, that makes sense.
Yeah, but I got 498 too.
Okay, that sounds good. Yeah, so the lower limit is the x minus 1.96. That part of the parentheses. There's like an x minus, and then there's an x plus.
Okay.
So the lower limit would be the x minus 1.96, blah blah blah. You know.
And the upper limit, the positive.
Exactly. Yep. So it's asking for the upper limit in question 8. And I got 553.685.
Okay. I got 554. So 53 point what?
685.
I'm sorry, can you repeat that one more time?
Yep. So the answer is 553.685.
I'm just going to go back after and do all of these.
Yeah.
My answers all match up.
Okay.
Number 9, I got increase. What would happen to the width of the confident interval if Gina increased the sample size? I put increase.
Would it be increase?
I put decrease. I put decrease, and the reason why I put that down, where is my answers here? 553. Yeah, so if the sample size is increased, basically what you have is you've got 1.96 times 113 divided by the sample size. And so if you increase that sample size, you increase that bottom number. And so what you end up with, let's just say right now we've got 113 divided by 8. That's what it comes out to be. So 113 divided by 8 is like 27 or 28, something like that. But let's say you increase the sample size. Let's just say that we make the bottom number like 20. or 100 even. You know, the sample size is going to go down from 27 to like 1. So
well, if you even just think about it, maybe I'm thinking about this wrong, but if you think about your sample size, when you're taking such a small, narrow window, you're bigger. But when the bigger the spread, the less your numbers, correct? So it would decrease because your spread gets bigger.
Yeah. Does that make sense, Alan?
No, it makes sense what you're saying, but like what I wrote down here, it says what happens to the width of the confidence interval. So this is my notes.
Okay.
As the level of confidence and the sample size increase, and then the two other things that they wrote down, it was like as the level of confidence increases, the width of the confidence interval increases, and then the other part says, as the sample size increases, the width of the confidence interval decreases. Okay, so that's the second part. You're right.
So when we're talking about the width of the confidence interval, we're talking about the space between the lowest number and the highest number.
The highest numbers, yeah.
Yeah.
Yeah, it says here, it's part. It says, as the sample size increases, the width of the confidence interval decreases. And that's what that's the question. That's what the question is asking here.
Yeah.
You just looked at it flipped the other way. That's the hard part. Like even like next week, the wording, it's just slight variations, and you're like, you have to really think about it.
Yeah. So I'm guessing 10 is increasing.
10, I put increase. Yep.
Yeah.
Yeah. So if you change it from a 95% to a 99%, what you're doing is you're actually increasing that number from 1.96 to like 2.5 something. There's an actual constant. There's a number that's in the book that correlates to 99%. But basically that number increases. And so if you increase the number, you also increase the confidence interval. You increase the difference between the lowest number and the highest number. So yes, 10 is increase. Are we good so far? Okay,
So
question. Sorry, go ahead.
So for 11, it says what sample size do they need? So then in other words, they're giving you like pretty much everything. You just need to solve for it to find n, and I got 246.
That's what I got. Yep.
And what formula was that?
That
It's
one.
in the
If you have it handy, don't worry about it.
it's n
Yeah.
equals parentheses the C score times the standard deviation divided by the m something.
Okay.
We're
And then
looking
it's
for
like-
the sample size. So let me show you on my notes here. Sorry, it's a whole bunch of chicken scratches, but
No, it's
anyway,
okay.
it's the same thing. So there's that x minus whatever, and then here's the x plus whatever.
Just that same as above the
Mhm.
limit, upper limit formula.
Yeah, exactly. So what we're looking for is we're only interested in the margin of error, and this part of the x minus, this part is what represents the margin of error. So we just plug and chug everything, and we'll solve for n because that's what we're looking for.
Okay. Let me share my screen. Let me see. Okay. Yes, this one is on screen. Can you guys see it?
Yep.
Okay. So this is the formula that I got. Where is it? I don't know if you guys can see it.
Let's see.
So
No.
n is equal. Can you guys see it?
I
You're
can
just
see
showing
me.
it.
Oh wait. Hold on. I think it's just saying it goes the code or not. But I'm going to share it with
Oh.
Stephanie. Okay, Stephanie, can you see it now? Okay, I can see now.
Yeah.
Can you see
hold,
this formula right there?
hold real still.
N
Equals. Yeah.
So I feel like that's the formula that I got, and then that's how I got the answer. So instead of moving all those letters around, that's just a formula to find the sample size.
Gotcha.
So Z times the deviation
Over m,
over M. Okay.
and then square.
We squared it. Okay.
Nice.
Thank you.
Okay.
And then for 12, I was doing it and I got stuck because let's see. I was trying to find so I found like the first part, but then the second part where you subtract, because we're trying to find the lower limit of 95%.
Mhm.
So do we use 111,000, or like do we use the 100,000?
I'm pretty sure we use 111,000 because what we're doing is we're trying to find the lower limit of the 95% confidence interval. So you take that equation that correlates to 95% confidence, which would be the 1.96 number plugged into everything. And what it's asking for is you have the x with the line over it minus 1.96 times sigma divided by the square root of n. And we found out above that they give us the mean. They give us x with the line over it, and that's 111,000. And anyway, after I plugged everything in, I came up with 99,002. 99,002. It's a weird number to say. Let me show it on the screen. Just that way you know what I'm saying. Here's my answer right there.
Let's see. Hold on.
Right there.
Okay. That makes sense.
Yeah.
1,002.
99,002. Yeah. That's a weird number to say out loud. So anyway, that's what the lower limit came out to.
And then for the upper limit, it's x with the line over it plus 1.96 divided times sigma over the n squared, the n square root of n. Right?
That's right. Yep.
Okay.
And for that one, I came out with 122,998.
Do you put your commas in?
I do. I mean, they are in. I don't think I put them in initially, but the computer does it for you anyway.
Okay.
So, yeah. Either way, I think is fine as long as it's the right number.
So 122. What was it again?
122,998.
Got that number? Transverse.
Yep. And then for question 14, this was straight out of the book. I put all of the above.
Okay, that makes sense. I agree.
It's funny because the question actually says there's 3 requirements that need to be checked, and they only give you 3 things. So it's
that's
like,
true. Yeah.
so you have to put all of the above. But I checked in the book, and that's exactly what they are. You have to have all 3 of those for when computing a confidence interval.
Okay. Well, I'll go ahead and submit it since I'm the unprepared one. So let me submit.
I feel like we've all been there.
I know, but I
So
think
far this semester, it stinks, but we've all been there.
number 9, unless I marked it wrong, came out wrong.
What was it?
We marked increase.
For number 9, I put decrease.
Oh gosh, I think I just forgot to change it. That's right. That was that conversation we had. Okay, so then other than that, it's 100.
Okay. Well, let me submit it here.
I can't remember when you have to resubmit. Does it save your answers, or do you have to put them all back in again?
When you resubmit, you have to put them back in again. So I can run through them with you because I got 100.
Okay. Okay. I thought maybe I could copy it, but it might be faster if I just run through them with you. If you don't mind.
Oh yeah, that's totally fine.
Yeah.
So whenever you're ready, just let me know.
Okay. Get on the right week. Oh my goodness. Okay, I'm ready. Number 3.
Okay, so number 3 is 16.450.
16.450. Okay. Number 4.
4 is B.
Okay. Number 5.
5 is 526.
526. 6.
6 is 27.685.
Okay, and 7.
7 is 498.315.
315. So 498.315.
Yep.
Okay, number 8.
Question 8 is 553.685.
Okay. 553.685.
Mm-hmm.
So number 9 is decrease.
That's right. Yep.
So number 10 is increase.
Mm-hmm.
Okay. Then number 11.
11 is 246.
246. Then number 12.
12 is 99002.
Number 13.
13 is 122998.
122998.
Yep.
And 14 is all of the above.
Correct.
Okay. Thanks, guys.
You bet. Thank you, Stephanie.
Okay, so we'll see you Thursday night at 8. Is that correct?
Thursday at 8. Yep.
Okay, we'll see you then.
All right. See ya.
Bye, you guys. I'll post.
Okay. Sounds good.